Hi, everybody. This is the first lesson in Unit 4, Chapter 4. Um, and this is starts on page 181, and this is on factoring polynomial expressions. So we're going to start by just trying to connect factoring and multiplying. So in previous lessons, we've learned how to multiply a monomial by a polynomial, which is you take the outside factor here and you multiply by that one and you multiply it by that one. So I get 2x squared plus 10x. And we multiplied a monomial by binomial times another binomial. And we go first, outer, inner, last. So we get x squared plus 3x plus 1x gives us 4x plus 1 times 3 is 3. And we also multiplied two binomials together to make another binomial. That is only when we have the difference of squares, right? So we've got something like some a minus b times a plus b. We're going to get the first term, which is x, this time squared, minus the second squared, 5 squared. So that's going to be x squared minus 25. And that's a difference of squares because these two terms are both perfect squares, and it's subtracting. That makes it a difference. Okay, so we call what we just did, we call that multiplication when we're just working with numbers, 2 times 4, 7 times 312, whatever. When we're working with polynomials, we call this expanding, okay? So it's the parallel to multiplying numbers. And then we need to be able to undo that, and we call that factoring. We're going to pull out factors. So let's just start with removing a common factor. So we've got, in this example, we've got 2x squared plus 10x. And if I look at this, I can see that this can be divided by 2, and this can be divided by 2, and they can both be divided by x. So that's going to be 2x, and I'm left with x plus 5. In this one, you don't know how to do this yet, but we're going to learn. This is going to factor into x plus 1 times x plus 3, which we know because just up here, that's how we got the x to the x squared plus 4x plus 3 was by multiplying these two together. And this is a difference of squares, and we factor that into x plus 5 or x minus 5. And of course, it doesn't matter what order these are in, these two factors, or these two factors, or even these ones, although it is a convention that we put the monomials out to the left of anything that's in brackets. Okay, all right. Um, let's look at finding the greatest common factor. So um, this just seems overly confusing. Um, Read it if it helps. I'm just going to talk you through the example. Okay, so what we're going to do is we're going to look at our two things and we're going to find the common factors, the greatest common factor. So if I look at my 8 and my 20, um, for numbers, it can be really helpful to do that prime factorization bit we did. So let's do that. So 8 equals 2 times 2 times 2, and 20 equals 2 times 2 times 5. And I put the 5 out there intentionally because this column has 2's and this column is full of 2's. So my greatest common, that's supposed to be a C. My greatest common factor is going to be 2 times 2, which equals 4. So that's my greatest common factor of those two numbers. So most of the time, the numbers we're going to give you, you probably can just look at it and see in your head, if you know your times tables, what the common factor is for the numbers. So my common factor here is going to be 4. And then I look at the x squared and the x, and what's the highest degree that both of them have, and that would be x to the 1. So that's going to be x, just x. And this has got y squared, and this has got y cubed. So the smaller of those is y squared. There you go. There's the greatest common factor. I guess I just did it by inspection. I filled these notes out a couple of days ago, and I didn't read them before I started recording. I'm sorry about that. And this is important that if all the monomials are negative, we usually consider the greatest common factor to be negative as well. Okay, that's just, again, that's the convention we have. Okay, so the greatest common factor of these. So if I look at the 12 and 15, that's 3 is the biggest number that factors into both of those. I've got a and a squared, so that's going to be a, and b cubed. So that's going to be b. All right. As always, I encourage you to pause the video and try these on your own before you come back and check it. This is going to be 6x cubed y squared. This is going to be, I'm not going to have a number here because I've got a coefficient of 1 here and a 2 here. So I just, I'll have a coefficient of 1, but I don't write it down because mathematicians are lazy and we don't do that sort of thing. I can factor out an a from both of them. I can't do a b because there's no b over here, but I can do c squared. And then over here, all of my coefficients are negative, so it's going to be negative something, negative 10. And then looking at the a's, it's going to be a squared b. All right, go and do questions 1, 2, and 3. Bye.